All right, scholars, good morning. We are now here at activity for processing 2.4, which is the video we want to watch before we attempt cooldown 2.4. Cooldown 2.4 is going to ask us to look at an equation. This is the equation of a cubic function. And they're going to want us to then find the zeros of this equation. The zeros of an equation go by several names. So you're gonna hear me use these words interchangeably. Zeros, x-intercepts, and sorry, I meant to write horizontal. Someone was playing Nipsey in the background. Kind of distracted me there. All right. Horizontal axis intercepts and horizontal axis. When we talk about axes, it's this axis here. So the horizontal axis is a fancy way of saying x-axis. Horizontal is this way, so this is the x-axis right here. I write this in black because it makes sense. Okay. I believe there's one more name that they use, but I'm not sure if we're going to use it in any New Year lessons. But they also call them roots. Okay, so these four terms are synonyms. They mean the same thing. There's just different ways to call them. And there are specific times when they're used, but you'll see me use them interchangeably so that you grow comfortable with these vocabulary terms being used. All right, let's get into finding zeros, or if we want to call them x-intercepts or horizontal axis intercepts or roots. Whatever you want to call them works for me. All right, let's get to it. Now, in order to find the zeros of this equation, we need to use the zero product property. What the zero product property told you back in the day is that, like, if you have y equals 2 times 3 times 0, then we can assume by multiplying these three factors, these are called factors, that we're going to get a product of 0. So it's called the zero product property. All because as soon as you get 1 0 as one of these three factors being multiplied, it resets, or rather sets the value of y to 0. So you get a y value of 0 when one of these factors equals 0. Let me show you two more possibilities here. So let's say instead of the first one here, let's say the 2 was a 0 instead. Okay. You will notice that you will get a product of 0 because the first factor was 0. Doesn't matter what these are. As long as one of these three is 0, that's what you're going to wind up with. I'll show you the third equation here as well. As this is 2 times 0 times 7. Also gives you 0. You will see that these three equations had the same factors, 2, 3, and 7. And I replaced either the third one, the first one, or the second factor with 0, and they all yielded the same result, 0. The reason I bring this up is because this property here will apply up here. So we can pretend that these three quantities are these values inside parentheses. So we got this quantity x minus 3, that's a factor. We got the quantity x minus 1, that's the second factor. And we got the quantity x plus 2, that's the third factor. So we can treat these as if though they were similar to this equation, where if just this quantity or this factor, if it equals 0, that means this whole thing will turn into 0. This entire equation will become 0. So that's what we're going to try to do here. And if you're in your notebook, this is example 1. And this is the problem you want to write down in your notebook there. Okay. So what we need to do here is we're going to set x minus 3 equal to 0. We need to find out what value of x would make this entire factor equal 0. That is found by setting the quantity equal to 0 and solving for x. This is a one-step equation. So if x equals 3, that's going to turn it into 0. And I'd like to actually prove it to you. Now, it's not required for today's cool down for you to prove it, but I'm giving you some information here from Algebra 1 as a reminder. So let's say, let me go back to this blue here. Y equals... So we're going to substitute a value of 3 here, here, and here in place of x. Okay, so here we go. 3 minus 3 is 0. 3 minus 1 is 2. 3 plus 2 is 5. So if we multiply 0 times 2 times 5, so now we can say confidently, because we have proven it, that when x equals 3, y becomes 0. Why? Because 3 minus 3 is 0. 0 times this will turn y into 0. There is a proof. Okay. All right, now let's go ahead and practice finding the other values of x that would make this y value also into 0. So this is one of the answers. X equals 3. There are 2 more answers that we'll get from the second factor and the third factor. Okay. So for the other ones, I will not prove that they work, but you can, if you wish, substitute your x value back into the equation and verify that it will turn y into 0. All right, let's go ahead and do the second quantity there. X minus 1 equals 0. And we're going to solve for x. All right, x equals 1. And then the third one there, we're going to set it equal to 0. So there are 3 values of x that will give you a y equals 0 statement. Those 3 values of x are x equals 3, x equals 1, and x equals negative 2. 1, 2, 3, okay? So I'm actually gonna write them beneath. So this factor gave me an x value of 3. The second factor gave me an x value of 1, and the third factor gave me an x value of negative 2. Now you may notice a little something there. Mister, I noticed that all you do is switch the sign. Yes. I wouldn't say that's a shortcut that's always available, but if you see the opportunity to do so, go for it and take it. We're actually going to go into another example right now where it's not as easy to do that because we're going to actually have to deal with some fractions. Okay. Now, for the sake of this problem, I actually would like to show you what that looks like on a graph. Okay, remember, this is the x value. This is the x-axis. That's the y-axis, okay? Horizontal, vertical. Now I'm going to go ahead and plot x equals 3 right here. I think that's gone. That's what happens when you let people borrow your markers. They don't know how to put the caps back on. All right. and -2. Okay, so if we were to draw a graph, it goes through -2, 1, and 3. Okay, this coordinate pair here is -2, 0. You see right there, x equals -2, and right there, y equals 0. Now I'm not going to do this over here, but the same can be said of the x-intercepts 1 and 3. Now something you're going to learn later, because I'm going to draw something, you're going to be like, what? This actually produces a cubic function, but this is not important right now. The only thing that's important is these 3 points here, okay? You'll learn how to create this little snake, this cubic graph, some other time, not today, okay? But the one thing that we are learning today is that this graph has these 3 zero values at x equals -2, 0, 1, 0, and 3, 0, where the x value, if you plug it in here, will turn y into 0. Okay, so let me just put my last bit of information here. There you go. This chunk of information correlates and is related to this particular chunk of information up here. All right, I'm gonna go ahead and hop into the next 2 examples. So if you wish, you can skip 2 lines in your notes, and let's go ahead and begin example 2. We're gonna practice finding the zeros and then sketching a graph. Now, sketching the graph is not a requirement of the cool down, but they are gonna ask you to analyze the graph. So I strongly believe that by sketching a graph, it's going to give you the ability to analyze a graph. Because if you can create it, you can analyze it, right? Just makes sense. Okay, so example 2 brings us to the following equation. Okay, I guess we don't have the fractions until example 3. Baby steps, right? Okay. So we have the factors x plus 3, x plus 1, and x minus 2. We're going to apply that same technique that we just did to the last one. Okay, I'm going to draw these arrows so you know where my work is at for each of these. So I'm going to set x plus 3 equal to 0. I'm going to do the same for x plus 1. I'm going to do the same thing for x minus 2. Okay, there we go. Okay, here's our first 0 or x-intercept or horizontal intercept. There's the first one. Here's the second. And here is the third. Bada bing, bada boom, bada ba. All right, so how do you graph these things? Okay, sketch yourself a nice little XY axis and then plot these 3 points along the x-axis because these are x values that are being described here. So we got one at -3, -1, and +2. Okay, there go your dots. All right, this graph that I'm about to do, you don't know how to do it yet, but I'm going to do it for you either way, just so you can kind of visualize what we're going to do in the future lesson. All right, there you go. So we have just here alone, we have looked at a cubic function or an equation in this case. We have found the 3 zeros from the 3 factors, and then we plotted those 3 zeros on the x-axis, okay? All right, let's go ahead and hop into that third example where we actually do take a look at a case where we have fractions. This is go ahead, skip 2 lines, example 3. And once again, you will notice that I'm not stopping much because you can pause the video and do the examples for yourself because this is something, an activity for you to process and attempt these problems at your own pace. Okay, here we go. Ooh, okay, good. Ooh, I made this super spicy. All right. What was I thinking? What was I thinking? All right, let's do one at a time here because these are a little beastly here. Okay, so the first one here is a two-step. This is going to be a two-step, different from the last ones we just did. Okay. So the second step, now that we have 2x equals -1, we want to isolate x. We're actually going to divide because a product of 2 times x means we can undo it by dividing. All right, divide both sides by 2. I was going to write in blue again, but it's fine. Okay. Let's hop into the second factor there. And remember, you can pause the video, try these out for yourself, okay? Because we're on example 3. This is where you're supposed to try these things out. So if you're just watching it, you're watching me do it without trying it for yourself, it's kind of losing the purpose there. Okay, once again, we're gonna go into the second step of our equation there. And we get x equals 2/3. I like this one. Those are the kind of questions that I love to ask. I just thought if I had wishful thinking, it would come back to life. A la basura. Okay. So the third one there. Oh, it's already solved. That's a freebie, but it can be tricky though, because you're all like, wait, what do I do there? What do I add? Do I multiply? Do I subtract? Do I divide? You do nothing. Leave it alone. All right. There we go. We got our 3 roots there. Now we're going to go ahead and plot them on our graph. Now, actually, let me do something else here. This is hard to visualize, for me at least. When I see a fraction, it's like, where the heck do I plot -1/2? It might help to actually turn it into a decimal. And if you don't know how to turn this fraction into a decimal, ask me at some point, come to office hours. I'd be more than happy to show you how to do it. But real quick, just divide 1 by 2 and your calculator will give you 0.5. If you divide 2 by 3, you're gonna get 0.66. You're gonna get something longer, but you can round off right here, okay? Okay, so our 3 factors we're gonna plot are x equals -0.5, x equals 0.66, and x equals 0. So let's get to it. -0.5 can be found, how about here? Between 1 and 0, 0.5. So there's my first dot. Let's put a positive 1 over here. So I can say 0.66 is kind of like right there. So I'm sketching right now, which means it's not precise, it's not exact, but it's a great estimation of where these points are at. And if I showed this to a reader, they'd understand that -0.5 is between -1 and 0, and they'd also understand that 0.66 is between 0 and 1. All right, so those are our 3 points there. And once again, I'm gonna go ahead and plot that cubic function through it. Okay, I don't like mixing the markers. They get all messy like that. Okay. So ladies and gentlemen, I'd like to just re-explain here. We looked at an equation that had 3 factors. Each factor gave us a 0, and then we plotted those zeros here on the graph. All right, that's me. Thank you for watching. Good luck. Have fun. Till next time.